Conic sections are curves that are created when you slice a cone by a plane. The four conic sections are the circle, the hyperbola, the ellipse, and the parabola. I've done a video segment on each of these conic sections, and this one specifically is geared towards the circle. The other ones are listed in the description with a link in case you want to go back and review either the information about the parabola or the hyperbola or the ellipse. Now for the information about a circle. A circle is a locus of points that are equidistant from a fixed point called the center. This distance that the points are from the center is called the radius. So if you fix your point of your center and then you have a fixed distance and draw all of those points, this outside edge is our circle. So actually the center is not a point that's part of the equation, but it's the values of x and y that make the equation true are that fixed distance away. Now we can kind of develop the equation for a circle by following the description of what it is defined to be. So remember how to find the distance between 2 points on a plane? The distance is equal to the square root of the subtraction of the x coordinates of the point, quantity squared, plus the subtraction of the y coordinates, quantity of the points, quantity squared. And this was just by an application of the Pythagorean theorem. Now the distance in our circle is that fixed distance r. So I'm actually going to call our fixed distance r, and the points that we're trying to find the distance between, that fixed distance, is from a general point on the curve and the center. So for my x sub 2, it's just the x coordinate of the point on the circle minus my x sub 1 is the x coordinate of the center. So h, quantity squared, plus, and then the y coordinate is a point on the circle, y, and then minus our k coordinate from our center. Now technically I have the equation for the circle here, but it's a little bit messy with the radical in it. So we just go ahead and square both sides to get rid of that square root and write what currently is on the right hand side over on the left and what currently is on the left hand side over on the right. So when I square this square root, if what's under there is positive anyway, I'm just going to get that positive value. So I have x minus h quantity squared plus y minus k quantity squared is equal to r squared. And that is our general equation of our circle. So now if I have an equation, I need to put it in that form to identify the center and the radius. Or if I have information about the center and the radius, then I can just plug those numbers back in here to get the equation of the circle. Let's look at our first example. So here it says, find the center and radius of 3x squared minus 6x plus 3y squared plus 30y plus 30 is equal to 0. Now, when you're looking at the idea of the equations that you could get for conic sections, if I don't have a degenerate case, so if I have a case that's not a degenerate case and it's not one that has been rotated, so it doesn't have an x, y term in it, then when I have both variables squared, I'm either going to have an ellipse or a circle or a hyperbola. Remember with the parabola, one letter is squared and the other one's not squared. Now, when not only the both letters are squared, but the signs in front of them are the same, you're down to either an ellipse or a circle. And when both variables are squared and exactly the same number is what you have as the coefficient in front of your square term, then that's when you have a circle. Again, as long as it's not a degenerate case. So here, my x and my y are both squared. The coefficients in front of both of them are positive 3. So I have a circle as long as I get a curve. Now, when I go would want to write it in this form so that I can identify my center and my radius, I need to have a 1 in front of my x squared and y squared, and I need to complete the squares. So what we're going to do is first we'll look at this, and it's nice that the terms with the x letter in it are next to each other. And so we're going to write that still as 3x squared minus 6x, but we're going to leave a space for completing the square. And then plus 3y squared plus 30y, leave a space for completing the square, is equal to, and subtract the number term, that minus 30 to both sides to get it on the other side. And now with a circle, if your coefficients in front of your square terms aren't 1, divide everything through by whatever that number is, even if it gives you fractions. You need to have the coefficients in front of your x squared and y squared terms 1 to do your work with finding your information for your circle. So we're going to divide everything through by 3. And we get x squared minus 2x space plus y squared plus 10y space is equal to negative 10. Now we want to complete the square. So for the x's, take 1/2 the coefficient of the middle term, so 1/2 of negative 2 is negative 1, square negative 1, that's 1, and add it to your binomial so far with your x's, which will make that a perfect square trinomial. And when you add it to the left side of the equal sign, you also have to add it to the right side to be fair and keep it balanced, to keep the equation true. And now for the y's to complete the square, take 1/2 of 10 is 5, and 5 squared is 25. So I'm going to add a 25 to both sides. Now, I want to factor each of these perfect square trinomials that I forced. And also, just to remind you that when you're completing the square and going to the factorization of a perfect square trinomial will be your open parentheses, your letter, and then what follows the letter is always what was half your middle. So even if you did have a situation that had fractions, writing out what half the middle is and then quantity squaring that value lets you know what to add in order to make it a perfect square trinomial, but keeping that step of what half your middle is actually lends you to the factorization. So for the x squared minus 2x plus 1, that's x, and then half my middle was negative 1, so it's x minus 1 quantity squared, plus the factorization for my y squared plus 10y plus 25. Well, half of 10 is 5, so that's going to be y plus 5 quantity squared is equal to, and then negative 10 plus 1 plus 25 gives me 16. And so my center is, remember, it's x minus h quantity squared plus y minus k quantity squared is equal to r squared. Your center is hk, so it's what you would plug in for the x and y to make those quantities 0 is how you can kind of think of it. So my center is 1 comma negative 5. And then my radius, well, my right-hand side is the square of the radius. So my radius is the square root of 16 or 4. So there's an example if we're given the equation and we want to find the information out about a circle. The next thing we're going to do is have information and then write the equation of the circle. All right, now let's look at an example where they give us information about a circle and we are to find the equation of the circle and some other aspects about the circle. So here it asks us to find the equation of the circle with center at negative 4, 5 that passes through 1, negative 7. And then find the area of the circle and the circumference of the circle. So first of all, I know that my equation of the circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. And h and k is the center, and I already have that. So my h is -4, and my k is 5. So what I really need to do is still find my r so that I can put that on the other side and square it. Well, remember, r is your fixed distance between your points on the circle and the center. And it does tell me a point on the circle. So I just need to find the distance between the point on the circle and the center in order to find my radius. Well, the distance between 2 points on a plane is the square root of the difference of the x coordinates quantity squared plus the difference of the y coordinates quantity squared. And it's our fixed distance now that's the radius, so I could actually just call this r instead of calling it d for this particular application. Well, it's easier to just kind of erase and replace with this to make sure that I'm keeping straight with my signs. So let's call the point that it passes through my x sub 2, y sub 2, and my center x sub 1, y sub 1. So each ordered pair is an x comma y, and then one of the points is sub 1s and the other point is sub 2s. So I have x sub 2 is the number 1, minus x sub 1 is the number -4, and then y sub 2 is -7, and y sub 1 is 5. So doing this kind of bookkeeping helps a lot of times, especially if you get distracted by something and then you've like lost track of your thought process. So here, r is the square root of, well, fixing your double negatives, that's 1 plus 4, or 5 squared, plus, this gives me a -12 squared. But remember to quantity square your -12, so that's -12 times -12, which is positive 144 for that part. So r is the square root of 25 plus 144, and you have to add these together before you do the square root. You can't break a square root up over addition or subtraction. It does not give you the correct value. So r is the square root of 169, which is 13. So then that gives me r is 13. And I can get my equation of my circle is x double negative minus negative is a plus 4 quantity squared plus y minus 5 quantity squared is equal to 169. So there is my equation of my circle. Now the area. Remember, the area of a circle is pi r squared. My radius is 13. So my area is equal to pi times 13 squared, which gives me an area of 169 pi square units. And then the circumference is 2 pi r. So I have my circumference is 2 times pi times my radius of 13. The circumference is, well, 2 times 13 is 26 pi. And then I double check to make sure I found everything. I have my equation, I have the area, and I have the circumference of my circle.